element of the array. In the case of any other material or missing material, we're going to append to the materials array a new subarray which will contain the wire color for the ambient. That means diffuse and ambient color channels will be locked, both using the same color. We'll pass white for the specular color. We'll set a default glossiness of 50 and a strength of 1. So the specular level will be basically 100. And we're also going to pass an undefined as the map, since we don't actually have any texture mapping in this case. Now that we have this function, we can implement another function to return the actual color in the point of intersection. Let's call it get diffuse color, and we're going to pass an index and the intersection information itself. The index is going to be the index of the object inside the objects array, which is equal, actually the same index, into the materials array. Using that, we will know which material to use. This is the reason we used a for loop with indices and not containing the object itself. So in this case, we're going to grab the object. That's the objects, the index. The color is going to be from the materials array with index, the index. The second element, that's the diffuse color. And the map will be from the materials, the indexed element, and sub-element number 6. This is the last entry in the subarray. Now, if the class of the map is a bitmap and not undefined, we can process the map and calculate the text cell color using the barycentric coordinates from the intersection, just like we did in previous lesson. First, we'll get the map face using the mesh op get map face from the object. We're going to use a hard-coded channel 1 at this point. The intersection number 2 is the second element of the intersection, is the index of the face. Now that we have the map face, we can get the map vertex 1, which is using the mesh op get map vert from the object, again channel 1, and using the map face x component. We can do the same for the second and for the third vertex in the face using the y and the z component. Now the uv coordinates are the map vertex 1 multiplied by the intersection's third component, which is the barycentric coordinates, taking the first barycentric coordinate plus the second map vertex multiplied by the second barycentric component, and the third vertex using the z component of the barycentric coordinates. So having the UV coordinates,